So welcome you all to a beautiful afternoon in Fairbanks, Alaska. Cold afternoon, maybe minus 10 degrees Fahrenheit. And today I'm here at the so-called Richardson side of the university. My name is Franz Meyer. I'm a professor for remote sensing at the University of Alaska Fairbanks. And specifically, I'm a professor for microwave remote sensing. And in this context, I have the pleasure today to welcome Sam Nichols from Capella Space in San Francisco, who is here in Fairbanks right now, doing some measurements in support of some of the satellites they have currently in space. So Sam, welcome to Fairbanks. Glad you picked Fairbanks at this cold time of the year.
So I work for Capella Space. We're a synthetic aperture radar company. Our satellites use a big radar dish to take radar images of Earth. The great thing about that is we can do it at night through clouds, anytime, get the same pictures. So we just launched 2 satellites about a month ago. Now I'm here trying to calibrate the satellites with an antenna and a bunch of radar electronics from this tent.
A heated fishing tent?
Yeah, so instrument in there is essentially a big telescope and a big amplifier with a signal generator. We're able to beam a signal up at the satellite in space. The satellite's up there listening for a signal, and it's recording the power, any signal that it receives. So if we know the signal we're transmitting from Earth, know the signal that we're receiving in space, we know essentially the gain of the antenna. And we also know the pointing accuracy of the antenna because we know exactly where we're transmitting from on Earth. That provides important calibration data for when we shift to taking actual SAR images. So the way this works is this is a hobbyist grade telescope mount, and this is an astronomy program that just happens to display any satellite that you feed it information for. So to begin a pass, you just select whatever satellite you want, then hit track satellite. The mount immediately slews to the satellite and starts tracking it. And then there's a signal generator inside that box that gets turned on, and an amplifier amplifies the signal, sends it through the antenna, and then you're beaming signal up at the satellite. And you can see satellites fly over pretty quickly, so the mount has to be fairly fast to keep up. And then the whole time we're transmitting, we're also logging the output power of the antenna so that we can compare that to the data that we get on the satellite. So being up in Fairbanks, super cold. This week has been pretty tame from what I understand. It hasn't gotten much below minus 10. I had a couple nights at like minus 15, but this tent actually stays fairly warm. Spent a while trying to install heaters all over this mount, heaters inside the box. Everything's powered, benchtop, power supply, pumping about 140 watts into the satellite and keeps it at a pretty good 20 degrees Celsius.
So Sam's work of doing antenna calibration and system calibration is very important so that companies like Capella Space can provide high-quality information about the Earth's surface, which will assist in the analysis of changes, in the measurement of dynamic signals on Earth, and also the management of hazards such as flooding and volcanic eruptions. So thanks, Sam, for the chat and for your time to spend with us in the cold.
Yeah, definitely.
How much longer are you going to be in Fairbanks?
So we're pretty much done calibrating the first satellite. I'm on the second right now. And if everything goes well, it shouldn't be more than another 2 days.
Okay, well.
Which is exciting. And then we'll be on to taking SAR images after that.
Well, have fun in Fairbanks. I hope you get to see the aurora and enjoy the environment, maybe go skiing. And thanks again for your time. And thank you all for listening.